Welcome to another data science deep dive on our technical track. In the following presentation, Kristie Wirth, data scientist at Zapier, talks about how she leveraged machine learning and NLP to automate the replay process for her customers. She walks through how her team built the bot and shares details on how to build something for your company. Enjoy!
Hello, everyone. My name is Kristie Wirth. I'm a data scientist over at Zapier, and I'm really excited to talk to you today about automating your support ticket replies. So to start with, why would you even want to build a bot that helps answer some of your support tickets? Well, one thing I noticed at Zapier, and you might notice too at your particular company, is that many support tickets are the same kinds of questions that you might be answering again and again. And anytime I see something that's a repetitive task, I always think about that as an opportunity for automation. And being able to answer some of these low value questions that are really simple to answer and that you're answering multiple times, being able to answer those with a bot can increase the efficiency of your support team, and it can allow them to work on higher value problems. For example, if the support team is seeing a lot of the same bug, they might be able to actually work on a fix for that bug as opposed to simply answering those questions. It also helps us to learn about our support tickets. So when you look into how the bot is performing later on, you can see that there are certain types of tickets that are repetitive, like I mentioned. But one thing you can do once you know what types are repetitive is maybe answer those questions earlier on in your help docs. Maybe you can build something into your contact form, and you can find bugs for your developers to fix. So you might have heard about text generation algorithms. So text generation algorithms like recurrent neural networks, GPT-2, are very popular nowadays. And I actually didn't use that kind of algorithm for my bot. So you might be wondering why I didn't. Well, that's because everything I've seen from these algorithms, they have a bit of a long way to go still. They're really great at learning style, but they're not great at learning content specifically. So instead of having computers try to write incredibly new text, I decided to simplify the problem space and instead leverage the awesome work that our customer champions and support had already done previously. So just a quick little fun example of where text generation algorithms are not quite addressing the problem space that they need to be is that you might have seen that a while ago an algorithm wrote a Harry Potter book. And just looking at the text here, you can see that it kind of sounds like a Harry Potter book, but the content is very strange and not quite right. So this is the sort of thing that I'm talking about of them not quite being at the caliber that I need them to be when showing that to customers. So here's an overview of how the bot works, and then we'll go into each of these steps in a lot more detail. So a ticket comes into support. The first thing I do is clean up that ticket to make it easier to work with. Then I vectorize the ticket, transforming the text into representations in a matrix instead, so something the computer can work with. And then I literally calculate the similarity between that new ticket and every other past ticket we've received, which sounds like it might be really slow, it sounds inefficient, but it's surprisingly fast when you set up your data in such a way that it's geared towards these calculations. And so I calculate the similarity scores. And by doing that, I'm able to find the past ticket in our data set that is the most similar to that new ticket. And once I identify that past ticket, I can look at the response that we sent to that past ticket. And the idea being is that if that ticket's similar to the new ticket, we said this in the past, perhaps it'll be helpful to say the same thing again. As you might imagine, there's some cleaning of that response to get it in a state that is actually something we want to surface to the users. But once that's done, we can send it directly to folks with having no human intervention at all in this process. So let's break down some of these steps. So one of the first things to do is to make that data set of all of your historical tickets and to make it in such a way that it makes the computations quick. So to do that, one of the first things is to clean up the tickets. So a lot of this was through trial and error. One thing I found that was unique perhaps to our support tickets is that when someone replied to an email requesting more help, the entire text of that email was included in the support ticket. And people can reply to the same email with very different questions. So I found that to not be helpful information and I removed it from the ticket. Similar with contact form text, we have some automatically populated text that wasn't information rich. I also found some people were copying and pasting certain error messages, and the formatting of those was messing with the algorithm. So I decided to clean up some of that JSON formatting. And then finally, in terms of email signatures and greetings, people might say thanks, they might use the same company address, they might say hello, but none of those are really information heavy statements. And so being able to clean up some of that helps standardize the text even further and improve the ability of the bot to detect similar tickets in a meaningful way. So I'm going to show a couple code snippets throughout this presentation to give you an idea, and I'll give you a link to the actual snippets later on. But one thing you do when cleaning up the code is you want to lowercase everything. So that will make it so that the tickets are a bit more standardized in their format. And then, like I mentioned, I removed emails, I removed populated auto text, and that cleaned up part of the ticket. And then there were a series of other things that I did as well that might be unique to your particular support tickets. Another thing I mentioned is removing signatures or greetings. And so how I did this is I used a package called Spacey. And Spacey is a natural language processing package that lets you learn a lot about your text. But one thing that's particularly helpful is they give you the part of speech of a given word. And so here I was able to identify which words were verbs. And this is important because if you think about it, things like greetings and signatures aren't really sentences. They're sentence fragments, and they don't have verbs in them. And so I was able to take this verb count and identify what things were true sentences in someone's ticket and what things were sort of fragments at the beginning or at the end that weren't particularly important to the question they were being asked. One of the next steps was vectorizing the support tickets, so transforming the text into a format that the algorithm can actually work with. And here is a simple count vectorizer, and you can see that it's just taking that sentence and transforming it into actual word counts for each particular word in the sentence. You'll also see some zeros here because once you start incorporating multiple sentences, then you're going to want the same columns for that entire matrix, but you're going to have certain words that appear in some sentences but not in others. For example, cat does not appear in this sentence, but likely appears somewhere else in a different support ticket. But this is just a simple representation of a vectorizer. There's a couple other things that I did that were a bit more complex and allowed for better results with the algorithm. So one thing I did was lemmatize the text. So this is to get the root words of every single word. For example, instead of including jumped, I would include the word jump. Instead of talking, I would transform that to talk. And so you're getting the meaning of the words, but not getting hung up on the conjugation. I also did something called TF-IDF vectorizer, which is a little bit more complex than simple count vectorizing. So TF-IDF is a measure of how important a word is in a given support ticket, but with respect to all of the support tickets. For example, I mentioned I work for Zapier, so the word Zapier appears in a lot of support tickets, and for us, that's not an important, meaningful word. So to break down what TF-IDF really means, the TF part of TF-IDF is a simple term frequency like you're seeing here, but the IDF is that inverse document frequency. And so it's an adjusted score, and a higher score here means that a term is frequent in a given support ticket, but isn't used frequently in other support tickets. Another code example here, It is less complicated than you might think to do some of these operations because a lot of these have been done before. And so using a package like sklearn, I'm able to import a TF-IDF vectorizer exactly as it is. I'm able to lemmatize the words using a custom function. I use something called n-gram range, which lets you not only look at word frequencies, but also the frequencies of phrases of 2 or 3 words, or perhaps more. I remove stop words. Stop words are just common words like and or the. You can add your own stop words, like we might add the word Zapier, and that just simplifies your text even more. And then I use a couple parameters that are relatively common in the world of vectorization to once again, just another defense against trying to get those common words out of the picture and focus more on those unique words that are meaningful. So once you've done all this, you've got your vector representations of text. You can save and refresh your data so that you have access to all of the great work that you've been doing with your historical tickets. So for us, I wanted to run a Python script nightly that would pull in all of the new support tickets and then work through all of those tickets to do the exact same cleaning and vectorizing operations that are necessary. So we used a software called Airflow that lets us run Python scripts on a regular basis. And then ultimately, I would save those to Amazon's S3 so that I could access those data later. So once you've got all of that background work done, then comes the really fun part where you can actually work on building the bot itself. How that works is you're going to send a post request every single time you get a new support ticket. And I just built a Flask app. You might want to use Django or something else, but some sort of app that can take in and respond to these post requests and use the logic to identify similar tickets. There's one extra step in the bot where we remove certain tickets that aren't eligible for that automatic response. And then we clean and vectorize tickets in exactly the same way that we did when creating the historical data set so that those ultimately match in terms of how they're formulated. Ineligible tickets were once again identified through some trial and error. Just through looking at our support tickets was the best way to understand when we wanted a bot to respond and when we want to make sure a human gets eyes on the ticket. For example, when people needed refunds or they wanted to extend their trial period or they had a request for a specific feature that we didn't currently offer. At least for right now, those require humans to do something in response to that ticket. So we excluded those from the bot. I also excluded spam because I didn't want to get into a reply chain with spam. And we actually have another classifier that labels things as likelihood of spam. So we interacted with that classifier here. We also removed non-English tickets. Right now, Zapier only supports English support tickets. And so I didn't want to confuse the bot and wanted to simplify the problem space yet again. So I used a package called lang detect that allows you to remove those. And then finally, I found that some tickets were just very short. And so being able to remove some of those that only had a handful of words just created less confusion for the bot as well. Here's some examples of how I removed ineligible tickets. I used natural language processing to identify some keywords or phrases that were connected to certain types of tickets that I identified as refunds or trial extensions. And then I just used keywords to filter those out. A relatively simple approach, but we found it worked well for us. So once you clean and vectorize everything, then you can get to calculating those similarity scores, like I mentioned. So I used a simple method called cosine similarity. And you might be wondering why. If you're familiar with other similarity scores, you might know that there's things like Jacquard similarity, Euclidean distance. And so why I didn't use some of those other methods? Well, I even tested everything from those types of methods to a more complex pre-trained word embedding model directly from Google. And I found that a lot of these metrics, even the more complex ones, performed just about as well as the simpler similarity metric. And so what I ended up doing is defaulting to the simpler method to keep my code cleaner, to make it more understandable, especially because I found no difference. So how this actually works, though, is that you can see here that we have two documents, and you can think of these as two different support tickets. So document A has the word transparency appearing in it 60 times, and it has the word supply appearing in it 40 times. Document B has the word transparency appear 20 times, but supply appears 50 times. And so you're able to map out those actual vectors that represent each document. And then you can calculate the cosine of the angle between those two documents. So as you might imagine, this is only two words and using those for similarities. And in the real world, you're going to have perhaps hundreds or at least tens and tens, dozens of words that you're working with. And so the problem space gets a lot more complex. It's a bit harder to map out visually, but the same premise holds true in terms of how you're calculating these similarity scores. Here's a quick code example. You can see that I pull in the exact vectorizer that I used previously to make the historical data set. I use a built-in function to calculate cosine similarities, and I sort those to find the most similar score. So there were certainly challenges along the way as I was working on this project, as you might imagine. One thing I wanted to do was an A/B test to see whether human responses versus bot responses were any different in terms of how people responded to them. So being able to log those results effectively to assign condition at this exact right time took some trial and error as well. You might realize that sending certain responses from the past has its own difficulties in terms of personalization. People's names might appear, people's emails, perhaps screenshots of personal information or links that were personalized to them. And so through doing a lot of digging into support tickets, I ended up developing some regular expressions, some general rules of thumb that we were able to replace these particular types of sensitive information on an automated basis and replace that with more generalized, personalized terminology to the new person. We also found that some responses that were particularly old were out of date. And so we ended up adding a filter so that only responses after a certain year were shown. And then there were just some deployment issues to work through, things like getting the Flask app to work effectively with our various environments. The A/B test results were incredibly promising. We didn't see a difference in activation rate, which for Zapier, people are building automations with our tool. And so activation means they build something and they're able to turn it on and it works effectively. So they're able to succeed with our product. And so that rate of success didn't differ between people who got a bot message and people who got a human message. And then the response rate didn't differ either. So whether people were responding to that bot, because we had it set up where if someone responded to the bot, then a human would look at their request to help them out. So that response rate versus the number of people responding to the first message from a human actually didn't differ. It was right about 40% either way. And then no matter what kinds of great quantitative metrics you have set up to measure how well your bot is doing, it's likely you'll want to do just a general eyeball of your results. That's how we learned a lot about which tickets to include, which tickets to exclude, how to exactly to clean up the tickets. So a few things I did here was I rated a sample as whether the responses were helpful or not. This gave us a general idea of how well the bot was working. I rated whether folks were feeling frustrated with the bot. We got about 8% with some slight frustration, but we were comfortable with that threshold. And then we identified common types of questions by creating templates to answer those more specifically. To give an example what that looks like, we wrote up a really nice response to when someone requests how to reset their password, because we found that that was a really common email and that it was worth investing just a little bit of time to send them a really nice response. We did the same thing for deleting account requests. And then if there wasn't a really nice curated response, that's when we had the model come in, because the bot was really good about working with edge cases. And so that was where we found it to be most useful. Here's a couple quick examples. Here's a question about whether we support a given feature, and we don't. So it lets them know that automatically. And here's a request for canceling their account. And so we find a similar ticket and ultimately let them know that this is how you can cancel your account. So here's just a couple of resources to end off my talk here. As you can imagine, some of this code gets quite complex, but I wrote up a bunch of samples for you that should be a great way to get started, and I'll share the slides later. Here's also some code for analyzing A/B tests, as well as a quick little plug for a Python package that I actually created that helps with a lot of machine learning tasks, with natural language processing tasks, and it's something I used throughout my bot to streamline processes. So thank you so much. Here's a link to the slides. Here is my contact information. Love to get in touch. And then a quick little plug for my company. We aim to make automation accessible for everyone. It's a great place to work. We're hiring a lot of data and engineering folks. So thank you so much. And I think we'll turn it over to live questions now.
That was Kristie Wirth, data scientist at Zapier, with her presentation on leveraging machine learning and NLP to create a bot that helped automate their company's reply process to customers. That's pretty awesome. If you'd like to watch more videos like this, you could subscribe to the DS Insider program, where you could see our complete on-demand video repository from a wide range of topics. You could find the link on the comments. Thank you.